Okay, I think we can resume. So, tapos natin yung hydro and then variable loading. Afterwards, if we have some more time, pwede pa tayo magkaroon ng practice problem. Kasi ibang items, walang problem solving. Para lang makita. Okay, so next topic natin is hydroelectric power plant. Okay, simple lang yung principle nito. In-harness natin yung energy from a flowing fluid na pababa. Okay, for example, if we have a dam, okay, then maglagay tayo dito ng penstock, dito dadaan yung tubig, yung pinaka-penstock natin, tapos dito yung pinaka-turbine natin. Yung energy na magta-travel from this point hanggang dito, i-harness ng turbine, mag-produce tayo ng power or hydroelectric power. Okay, and then yung basic parts niya, yung basic lang ha. Okay, sasabihin natin this is ito yung tinatawag na gross head, pinakamalaking head, HT, okay, or headwater na lang. Okay, H ng headwater. Okay, and then ito naman yung H ng tailwater. So if ever maka-encounter tayo. Okay. Ang in-harness nating energy is itong energy na to, from this point up to this point. So first possible question na itanong sa atin, yung madalas talagang itanong, what is the power developed? Okay? Power developed is yung difference in elevation. Nung dinerive natin to, that's simply parang somehow potential eh. Pero overall, na-derive na natin yan, yung power developed, that is gamma QH. Gamma QH. So this is the power developed sa hydroelectric power plant. Okay? Nasanay na tayo dito, this should be in kilowatts. Alam ko naman yung concept sir, na para maging kilowatts, ang unit nito, this is kilonewton per cubic meter, this is meter cube per second, and then yung height natin, meters. Okay? Ang pinag-aaralan natin dito sa hydroelectric, ang pinag-aaralan natin tubig. Ibig sabihin, yung part na yan, hindi nagbabago. That is constant. Kabisado naman natin sir, ano yung constant ng tubig? Gamma? So that is 9.81. Okay? Para simple lang yung computation natin, mag-stick tayo sa SI. So gamitin gamma, laging 9.81. Kung horsepower yung tinatanong, solve mo muna yung kilowatts, and finally, yung final answer, yun lang i-convert papuntang HP. Kasi mas madali yan. Okay? Then this is given. To solve Q, can use yung AV, area times velocity. Yung height, dito nagkakatalo-talo. Yung kailangan nating height, kasi na-substitute dyan, that should be yung H-net. Okay? Or the available head. Available head. Kung i-analyze natin, sir, paano nakukuha yung H-net, sir? Ang pagkuha ng H-net, i-apply natin yung principle sa fluid mechanics. Kasi tubig ito eh. Para makuha yung H-net, yung total head na madedevelop, okay, apply mo yung Bernoulli's principle. Naalala mo ba yung Bernoulli? Naalala mo ba? Yes, sir. Okay. Basic lang naman eh. Pag sinabing Bernoulli's principle, sir, may pressure head, okay, may velocity head, tsaka may elevation head. Tatlo naman yung head na yun eh. Yun lang yung tandaan. Pressure head, velocity head, elevation head. So, ibig sabihin, pag kailangan ko ng H, na substitute dyan, substitute ko lang. Pressure head, that is pressure over gamma. Velocity head, V squared over 2G. And then, elevation head, if ever meron. Pero, most of the time, ang nagagamit lang natin is itong dalawa lang. Okay? Ngayon, pwede ring makuha yung H-net, this is H-net eh. Pwede ring makuha yung H-net by simply looking dito sa setup. Kung given ito. Kasi kung given yung headwater, sa tailwater, this is H-net. Nandun yung H-net natin. Okay? So, paano makukuha yung H-net? So, that is simply by inspection. Okay? Pero ang tawag dito, hindi H-net kagad. Head gross muna. Gross head muna. Okay? So, kung titingnan natin, sir, headwater is equivalent sa gross head plus tailwater. So, lumalabas, sir, ang gross head equivalent sa headwater minus tailwater. So, this is our equation. Okay? Ngayon yung gross head, equivalent yan sa H-net pag walang losses. Kasi ang general formula, plus or minus, okay, minus head losses. So, ito yun. If losses is 0, equal sila. Pero pag may value, sinusubtract yun. Okay? Let's continue. And then ito, discuss natin yung head losses. Okay, yung solution sa head losses, na-discuss na yan sa fluid mechanics. Okay, ulitin lang natin. Alala pa ba yung losses sa head? Fluids. Na-apply rin kasi dito yun eh. Naalala pa ba yung Darcy-Weisbach tsaka Morse equation? Pag-compute ng mga losses. Anong formula ni Darcy? FL D squared over 2GD. So this is for Darcy. Okay, and then for Morse, tataas mo lang yung 2. That is 2 FL D squared over GD. This is for Morse. Okay, kasama pa rin yan sa hydroelectric power plant. Dapat familiar tayo doon. Okay? So if ever hindi binanggit ng problem, kung anong gagamitin yung head losses, assume Darcy. Pag hindi binanggit. Pero pag sabing Morse, use Morse. Okay? Ang palatandaan ko dito, kaya di ko nakakalimutan, kasi meron kami mga coding. Ganun lang naman eh. Kanya-kanyang diskarte. Okay? Since madalas naman magamit yan, ginawa namin to ng coding. Or ginawan ko lang ng coding. Ako yung gumawa kasi sa review namin dati, wala coding yan eh. So, di lahat ng formula may coding ha. So, pag meron kayong formula gustong tandaan, tapos hirapan kayo, gawin nyo ng coding. Gawin nyo ng mnemonics. Ang iniisip ko dito, kaya di ko siya nakakalimutan, iniisip ko yung kaibigan ko. Ay, yun lang yung kwento niya, simpleng kwento lang. Kasi sa batch namin, ay, lahat kami graduating, tapos meron akong kaibigan, hindi siya nakagraduate. Okay, so ang palayaw niya, Flavio. Hindi tapos na. So pag tinatandaan ko, head loss. Sino si head loss? Si Flavio. So pag tinatandaan ko, Flavio to. Dito, baliktad ko yan eh. Dito, graduate. Hindi, kabisado ko na yung head losses. Sino yung head losses? Si Flavio. So Flavio to, dito, graduate. Pag gagawing Morse, tinataas ko lang. Ano lang siya? Kanya-kanyang style. Okay, so meron na tayo niyan, head losses. Meron na tayong power. Ano pa dapat tandaan? Yung basic. Basic pa, may hindi pang basic eh, na formula. Hindi natin dito pa ibang basic. Sir, paano pag nagtanong ng specific speed? NS. Okay. Specific speed. NS. Okay. Pag nagtanong ng specific speed, these are the possible formula. Direct substitution lang naman. Okay. I don't know kung nadaanan sa fluids, pero recall na rin natin. So, specific speed is N square root of Q all over H raised to 3/4. Pag given Q. Pwede rin namang NS, makukuha yan sa N ay square root of power all over H raised to 5/4. So, yun yung mga possible formula ng specific speed. Okay? This is an empirical formula. Para gumana ng tama, NS should be in RPM. Okay? N should be in RPM. Okay? Q should be in GPM. Galon per minute dapat pag sinasubstitute dito. Okay? Power should be in HP. Horsepower dapat pag sinasubstitute dito. And then, height should be in feet. So, make sure kabisado lang yung units. Kasi direct substitution lang naman. So, pag nagtanong ng specific speed, hindi problema yon. Kung nagtanong ng specific speed, sir, bonus yun. For as long, kabisado ko yung formula. Wala namang gagawin kundi substitute lang. Okay? Substitute lang natin. Okay, last formula na dapat i-familiarize is the turbine speed factor. So, turbine speed factor. Or P. Ano ba sinabi ng speed? So, dun kasi sa penstock, paglabas sa penstock, for example, ito na yung penstock natin. Okay? Paglabas ng tubig dito, Okay, yung tubig na lalabas dyan, tatama dun sa blade ng turbine. Okay, example, ganyan yung turbine natin. Ng reason, iikot yan, magpaproduce ng power. Ganun lang yung basic concept. So yung energy na madadevelop dito, ito yung dahilan pati iikot yung turbina. Pag umikot na yung turbina, mag-generate na ng power. Okay? So, sir, pag tinanong ako ng turbine speed factor, nasan yun? Okay? O, pag tinanong ka yan, nakalimutan yung formula, madali lang. Okay? Turbine speed factor or speed ratio. It's also known as speed ratio. Speed ratio. Pag tinanong ka ng formula ng turbine speed factor or speed ratio, maalala mo na nasa pangalan, speed ratio. Ibig sabihin, ratio siya ng velocity or speed. So para di makalimutan yung concept, sir, output over input, output over input, output, input. Ano ba input? Sir, ito yung input natin, di ba? Ito yung input, that is yung jet ng tubig. Kasi paglabas niya dito, mabilis yan para jet. So that is velocity jet. Ang output natin, nung tinulak yan ng jet velocity, iikot yan. Tama? Ang output mo, yung pag-ikot. So, ang output mo, yung peripheral velocity. Yung pag-ikot. Peripheral velocity. So, hindi mahirap i-recall pag nakalimutan. May PJ. May PJ. Peripheral over jet. Ngayon sa, let's elaborate further. Ano ba formula ng peripheral velocity? Basic lang yan, sir. Yun yung umiikot. Sa dynamics natin, pag may rotation, ang velocity is simplify dn. Tama? This is jet velocity. A jet velocity. What is the speed at this section? So, pag meron kang height, ay tatranslate mo yung height papuntang speed. Tama? So, dun sa mga kabisado yung formula, alam na agad. Kung hindi mo maalala, yung height, i-transfer sa speed. Paano yun? Potential, i-transfer mo papuntang kinetic. Kasi kinetic yun yung speed. So, doon sa memorize, square root of 2gh. Pero kung hindi alam, dyan galing. So, mgh, 1/2 mv squared. Cancel. So, velocity is square root of 2gh. So, yun yung jet velocity. Square root of 2gh. Okay, kompleto na tayo. By the way, pag merong losses, di ba meron tayo hnet? Okay? Napagbaliktad ko yata, sorry. Ang hnet, that is hg minus head losses. Okay, tama na lang. And then yung hnet, that is potential or pressure head, velocity head, elevation head. Pag may losses, mina-minus pa rin yung losses dito. Laging subtraction yung losses, if ever meron. Okay. So, kompleto na tayo. Medyo mahaba lang discussion, pero yan lang naman yung mga ma-encounter natin. Yan lang yung practicein, ulit-ulitin yung sulat, and then maghanap ng problem solving na related sa mga yan. Kasi yun yung mga lalabas. Okay, so, let's try to solve some problem para ma-appreciate natin ito. Number 30. In Maria Cristina Hydroelectric Project, the available head is 140 meters. So, available head, yan ay hnet. Ayan na lang. Hnet. Okay, that is 140 meters. The water flow is 1 cubic meter per second. So, given yung Q, 1 cubic meter per second. The efficiency of the turbine is 95%. Efficiency ng turbine, 95%. Okay? And the efficiency ng generator, also 95%. Okay, 3-phase, 60 cycles, okay, delivered for 160 volts. Determine the estimated yearly income of the plant if the cost of generated electricity is equivalent sa the required Okay, yearly income. Okay? If the cost of producing the power is equivalent sa 0.6 pesos per kilowatt hour. Okay? Solution. This is an easy problem. Okay, masasolve natin to, hindi naman nakakalito, sir. Okay? Kahit wala kang formula or hindi mo alam gagawin, pwede ka mag-unit analysis for this problem. Sir, ang kailangan ko, sir, yearly income. Pag sinabing yearly income, ang unit niyan, sir, pesos per year. Yan yung kailangan mo makuha sagot. Pesos per year. Okay? So, kung titingnan ko analysis, meron ng clue. Okay? Gumawa pala ako ng way na ang lalabas na unit, pesos per year, kasi yun yung yearly income. Given na yung cost, binibenta natin yung kuryente sa 0.6 per kilowatt hour. So, makukuha ko na yung income ko. Ang kailangan ko lang, sir, cancelin ko yung kilowatts. So, substitute. So, multiply natin. 0.6 kilowatt hour. Okay? Find a way mag-cancel yung kilowatts. So, ano gagawin ko? Para mag-cancel yung kilowatts, i-multiply ko yung power. Kasi yung power, yun yung kilowatts na na-produce. So, anong formula ng power? Sir, gamma, Q, H. May efficiency. So, sama efficiency. I-multiply yung di-divide. May efficiency tayo eh. I-multiply yung di-divide. Sir, nagpo-produce tayo. I-multiply. So, i-multiply mo. Diba? So, ang unit dito, sir, kilowatts. Cancel. Eh, sir, meron pang R. Kailangan yung mapalitan yan. Di dapat per R, dapat per year. So, mag-multiply tayo ng conversion. Diba? Ang 1 year, ilang oras? So, dapat bilangin mo. Sir, nabibilang pa yun, yes. Constant yun. Pwede mo kang kabisaduhin na lang eh. Para lang kanta ng Jollibee. 8, 7, 60. Parang gano'n lang. So, hours. That's it. 7,000 ba?
Pag lahat mo efficiency mo.
Yes, i-multiply lang. Kasi,
Parang walang costing sa given.
hindi. Tinama ko yung given, yung sa inyo yung may problem. Kasi na-double type lang yung is 95, is 95. So, dalawa lang talaga. Okay, 8760 8760. Kasi parang Jollibee lang, pero bukas nagdagan mo ng konti. Ano ba yun sa Jollibee? 87,000. So, sa atin, 8760. Okay? So, 1 year, 8760 hours. Okay? Kompleto na tayo, we can now have pesos per year. Income per year. O, substitute na, sir. 0.6. Okay? Gamma, is constant. Ilan yan? 9.81. Hindi ko nalalagay units ha, kasi na-check na natin kanina. Q, tama unit. So, 1. Height, H-net na yan. 140. Efficiency, 0.95. 0.95. Okay? And then, 8760. Simplify, multiply mo. This is the income per year. Huwag kalimutan to. Pag nakalimutan yan, mag-multiply ka. 365 times 24. Pero mas maganda kung kabisado mo na. 8760. Lalabas na yung income natin. So, ang income natin yearly is equivalent sa 6,540,778.8 pesos per year. So, ito yung income ni Maria Cristina Falls. Yung iba, nilulooks pump to eh. Pero hindi nyo na kailangan looks pump eh. Madali naman tandaan eh. Okay? Ay, madali namang isolve. Okay? Iba, sir, basta makakita ko ng Maria, hanap ako ng 6. Okay, ganun yung coding ng iba. Pero hindi nyo kailangan eh. Solve nyo na lang. Okay, ito pa. Number 14. Sir, a hydroelectric plant discharges water at the rate of, okay, so we have Q, 0.75 cubic meter per second. Enters the turbine at, we have a velocity na 0.35 meters per second yan. Yan, minus per second, meters na yan, meters. Okay? With a pressure of 275 kilopascal. Okay? The runner inside diameter, so the diameter is 550 millimeter, while the speed is 520 RPM. Okay? The turbine efficiency, the efficiency of the turbine is 0.88 or 88%. We are required to calculate for the speed factor. Okay, speed factor. Madali ito, sir. Nakapaghandaan, na-discuss. Kaya appreciate lang, apply natin yung principle. Sir, speed factor. Naalala ko yan, yan yung P. Diba? Alam po concept yan, sir. Speed factor is also speed ratio. So, ratio lang yan ng speed. Tandaan ko yung ano natin, sir, that is PJ, peripheral over jet. And nalagay ko na equation. And then, alam ko naman yung basic, pag peripheral, that is pi dn. Pag jet, that is square root of 2gh. So, masasolve ko yan, sir. Yung tinatanong, eto na. This is given, given, given. Okay? Given, constant, h. Nawawala. So, i-solve mo lang si h, tapos na yung problem. Sir, how can we solve h? Yung h na yan, yan yung h-net pa rin. Okay? h na yan, yan yung h-net. So, paano makuha si h-net? Depende sa given. Sir, ang h-net masasolve. Kasi may mga given naman tayo eh. So, pressure head, velocity head, elevation head, minus losses. Yan yung general. Wala namang given na losses, 0. Walang elevation, 0. So, nandito tayo. So, elaborate further. Ang pressure head, that is pressure over gamma. Ang velocity head, that is v squared over 2g. I-simplify, now we can get h net. Dali na. So, 275, i-divide ko ng gamma. Ano yung gamma natin? 9.81. Okay, plus velocity, okay, 0.35 squared all over twice ng 9.81. Simplify, you get h na. Okay, so 28.039 meters. Since we have h net, finally we can get the speed factor. Okay, substitute. So make sure marunong lang sa units. Kasi sa substitute na lang to, baka sumablay pa tayo. Sir, pi is pi. Diameter, anong dapat unit yan? Ano dapat unit yan? Meter. So adjust ko lang, sir, that is 0.55. Okay? Then yung end, sir, is 520. Anong kulang? Sir, 60. I-divide ko pa ng 60 kasi kailangan RPS. Revolution per second dito. Ay, RPM yun. So make sure i-divide mo pa ng 60. So square root of 2, 9.81, then yung height, 28.0. Okay. 28.039. Okay, so yan yung kompleto. Makakuha na natin yung speed factor. Okay, dito nagkakamaling iba. Nakakalimutan mag-divide ng 60. So, ang speed factor natin is 0.638. Question. So, madali lang naman eh. Basta solid na yung foundation natin. pag-compute. Let's try number 15. Start with the given, sir. We have a hydroelectric power plant, 20 megawatt generator. So yung power na madadevelop is 20 megawatts. Okay? With an efficiency of 96%. Okay? And the hydraulic turbine efficiency of 80%. Okay? The total gross head on the turbine is 150 meters. So total gross head HG. Okay. So 150 meters. Okay. And the losses due to the friction is 4% ng gross head. So meron tayong losses okay, na 4% ng gross head. The runaway speed is not to exceed 750 RPM. So, speed, 750 RPM. Ang question dito is determine the flow rate of water. So, nawawala is flow rate. So, required Q. Okay. Volume flow rate. Kasi yung Q natin, the final unit should be in CFS. Pag sabing CFS, that is cubic feet per second. So, dapat yan yung final unit. So, madali na yan. Computein muna natin yung meter cube per second, convert na lang sa dulo. Okay, ganun yung pinakasimpleng gawin. Okay. So, analyze. Anong formula ba merong Q? Power cell. Diba sir, ang power is gamma QH. Okay? Ang given natin is actual power na na-develop. Actual yan na lumabas. So, actual yung gamitin. Actual kasi to. Okay? So, kung actual yung gagamitin, ano gagawin sa efficiency? Multiply, divide. Multiply pa rin sir, kasi power producing tayo. Tama? Multiply, multiply. Okay, now, analyze. Sir, given, constant, unknown, H-net. It should be H-net. Okay? Given. Pwede natin shortcutan para mas mabilis. Pwede naman natin intindihin lang. Yung H-net, sir, okay, is dapat 150 meters. Yun yung gross head eh. Equal dapat sila eh. Equal dapat sila. So yung H-net, sir, that is 150 meters kung walang losses. Kung walang losses. Since nawawalan ka ng 4%, because of the losses, yung 150, hindi na 150. Bawasan mo ng 4%. So, mas madali, multiply na lang sa 0.96. 0.96. Or kung baka malito yung iba, sir, baka di ko maisip yan. 1 minus 0.04. Basta ganun pa rin yun. 0.96 na natira. At least ito, nasa given sa atin. Okay? Pero 0.96 will do. So, ang H na talaga, or available head, na gamit lang natin, is 144 lang talaga. Okay, so meron ako dito. With this, makukuha natin yung sagot. Sa power, dapat ang unit ng power kilowatt. So, i-adjust mo lang yan. Gawin mo 20,000. Okay, gamma is 9.81. Q is unknown. Height, ito yung H-net or H available, 144. Efficiency is 0.96. And then 0.8. Okay, with this, makuha ko na yung Q. Ganun kasimple. $18.435. Sir, wala sa choices. So, kalma lang. Ano pang unit to? Sir, SI pa lang yan eh. Wala talaga sa sources yan. Kasi yan, ang unit yan, cubic meter per second. O, yan na lang i-convert mo. Final unit, feet cube. So, convert tayo dito. Basic lang naman yan, sir. 1 meter, ilang feet? Ilang feet? Paano man nakalimutan ba yun? Ilan? Sir, ang dali nun. 3.28 feet. Naka-cubic tayo, cube mo rin yan. So, final answer. Okay, 650.5. Okay? Cubic feet per second. So, choose the best answer. Obvious naman. Status. Okay, para magkaroon ng effective na review, gawin nyo lang yung lagi yung ginagawa. Okay? Ano bang ginagawa nyo parate? Sir, effective ba yun? Sir, oo! Ano bang ginagawa nyo parate? Nagre-review. Gawin nyo lang yung lagi yung ginagawa. Nagre-review. Pag gawin sa bahay, anong ginagawa? Tutulog. After matulog, syempre, nagpahinga lang. Anong ginagawa?
Tulog.
Tulog ulit. Kaya nyo lang, elaborate nyo lang. Pag yung ginagawa nyo activity, ito lang tip lang ha, alam nyo nakakatulong in preparation sa 102 days natin. Pagpatuloy. Nakakatulong pala eh. Kung alam mo yung ginagawa mo, di nakakatulong, ay itigil muna. Ay itigil muna. For example, sir, hobby kong manood ng movie. Eh meron tayong board exam eh. Pwede mo naman gawin yun after the board exam. So yung mga gusto mo, gusto mong gawin, okay, pero hindi nakakatulong, itigil muna. Okay, kung hindi naman masama, hindi naman kaya masamang manood. Pero kung nanonood ka ng movie, nag-movie marathon ka pa ngayon, hindi maganda. Kasi sir, we have a limited time, 102 days. Okay? So, madami pa siya kung i-maximize natin. Kulang na siya kung aksayahin natin. So, ganun lang kasimple. Now, let's proceed sa mga terminology. Okay, 1 point din yan sa board exam. Basic lang naman. Okay, the intake pipe to the hydraulic turbine is called? Nabanggit naman kanina yan. That is penstock, sir. Yung parts nung dam or nung hydroelectric. Penstock yung pipe. So, the hydraulic jump is used to? Okay, sir. By analysis, sir, reduce the energy of flow. Kailangan na mabasa para at least alam yun yung purpose niya. Okay, next type of turbine is ocean and then tidal. Okay. Ang lumalabas somehow dito is more on terminology. So, magbasa ng mga books regarding dito. Then, pasok tayo sa mga indicator na. Ito yung last topic natin for power plant engineering. So, mga indicators. By the way, kumusta nga pala yung mga baboy? Sa mga probinsya. Nagbakasyon tayo, binisita nyo ba? Malaki na ba?
Malaki na. Tinatay na.
Kinatay. Kasi, mag-alaga ulit. Kasi meron tayong celebration after 102 days eh. Sigurado yan eh. May magse-celebrate. Tama ba? Yun yung sigurado. Ang tanong lang, sino? Pwede ikaw or yung baboy. Pero I tell you, ikaw yun. Okay? Ikaw yung mag-celebrate yan. So ngayon, dun tayo sa variable loading. So topic natin, variable loading. This is an easy topic talaga. Kung titignan nyo yung handouts natin, nandiyan yung mga formula for variable loading. So, huwag mo munang tingnan, baka kasi malito ka, kasi sir, ang dami eh. Ay, nakakalito eh. Hindi ko nakukuha yan dati sir eh. So, simplihan na lang natin yung approach. Okay? I-solve natin yung mga basic question na madalas itanong and mga approach na dapat nating matutunan. Okay? Ang variable loading, bonus yan for those students or reviewee na alam yung formula. Kasi wala namang ginagawa, direct sub eh. Diba? Pero kung hindi mo alam yung formula, problema yan. Kasi Hindi natin ma-derive eh, yung iba dito eh. So kailangan sir, familiarization. So para hindi tayo mahirapan mag-familiarize, yung mga madadaling tandaan mo ng formula. Yung mga basic. Pag nag-drawing tayo ng load diagram, example, this is power. Okay, over time. Okay, sa load diagram. Pag alam mo yung basic drawing nito, may lalabas na unang formula. For example, ito yung loads natin. Okay? Basic lang ito. Alam mo na yung pinakamataas, ito yung capacity ng power plant. So, tinatawag natin itong plant capacity. Yan yung kapasidad ng power plant natin. Okay? Dinidefine niya ng problem. Sinasabi naman ng problem. This is the capacity ng power plant. Ngayon sir, by inspection, okay, this is our load curve. Okay? Anong tawag dito? Maximum load. Or tinatawag na peak load. Okay? Maximum load or mas kilala siya sa peak load. Okay? So sir, obvious naman yan. Ito yung pinaka-peak. O yan yung peak load. Ngayon sir, this is the plant capacity. This is the peak load. Meron tayong allowance. Tama? Ang tawag sa allowance na yan, yan yung tinatawag na reserve over peak. Okay? So yung basic logic na yan, o formula na yan. Wala kang i-memorize. Di ba? Parang logic lang naman siya. Capacity, peak load, so yung allowance, reserva. Reserve over peak. Kasi ang mga possible question, yan na yun. Determine the reserve over peak ng planta. So, hindi mo kailangan i-memorize yung reserve over peak. Concept o logic lang. Kung titingnan kayo logic sir, ang reserve over peak is simply plant capacity cap na lang, capacity minus peak load. So, yan yung first formula natin, reserve over peak. Nagdagan pa natin, sir, may mga tinatawag tayong factors dito, yung mga variable, mga indicators. Mga madalas na itanong na variable or indicator is yung diversity factor. Diversity factor. Okay. DF, diversity factor. Okay, so pag tinanong ka ng diversity factor, pag sinabi yung factor, madaling tandaan, laging dinidivide. Meron tayong divisor. Meron tayong ratio. Okay? So, sir, paano mo matatandaan yung diversity factor? Okay, para di makalimutan yung formula ng diversity factor, tandaan mo lang yung simpleng kwento na to. Okay? Sir, diversity factor, tandaan mo lang yung word to divert para mas madali maalala. Okay, so divert sir. So, paano natin nire-recall yan? So, pag diversity factor, divert, ang iniisip ko lang dati dito is yung mga kapatid ko. For example, ako kasi may mga kapatid akong maliliit. Okay? So, kung gusto kong ma-divert yung attention nila sa ibang bagay, dinadala ko lang sila sa mall. So, tinatandaan ko lang, SM. So, diversity factor, SM. Saan ano yung S? Sum. Ano yung M? Maximum demand. So, diversity factor is simply SM. Other factor na pwedeng itanong, load factor, LF. Paano naman yung LF? Load factor. Okay? DOCSPAM, madali ang tandaan. DOCSPAM. Okay, so palatandaan ko lang dito, sa amin kasi, okay, meron kami isang instructor or reviewer na inaasar nila. Okay, mukha daw siyang ganito. Hindi ko nakalimutan. 8. So, DOCSPAM 8. Ano yun, sir? Average over peak. Okay, so puro kalungan na pero effective. Ganun-ganun lang, sir. Maalala mo na. Diversity, SM. DOCSPAM 8. Reserve over peak, logic. Ano pa ba? Sir, capacity factor. Capacity factor, oh. Hindi nyo makakalimutan yan. Capacity, EE kayo, oh. AC. Diba? AC, average over capacity. Plant capacity. Okay? Yung mga basic, okay? Mga basic ito na mga possible na lumabas. So, this is the average or annual peak load. Okay, average capacity or plant capacity. So, SM, 8, AC, and then use factor. Sir, paano naman yung use factor? Ay, pag yung use factor, tinatanong, nire-relate yan sa capacity factor. Use factor tsaka capacity factor related. Para hindi mo makalimutan, daanin sa logic. Sir, use factor. Related yan sa capacity factor. Okay? I-relate mo sila sa time kasi tinatanong yung time. So, multiplier natin dito, time. Okay? Pag sinabing use factor, ang minumultiply na time is yung usage. Kaya nga use factor. Okay? Pag sinabing capacity factor, ang minumultiply na time is yung capacity. Ang computation nito, parating per year. Ibig sabihin, yung capacity niya in 1 year. Ilang oras ba yung 1 year? Sir, kabisado ko yan. Jollibee. 8,760. Yun na yan. So, ganun lang, ang simple. Relate mo lang. Use factor, usage. Capacity factor, capacity yan in 1 year. So, 1 year yan, 8,760. So, with that simple discussion, kasi yun yung mga madalas talagang lumabas. Okay? O, di mo na makakalimutan. Now we can solve. The rest, puro logic na lang. Sir, pag nagtanong na ibang problem, demand factor, ganyan, etc., logic na lang naman. Okay? So, let's have an example. Okay. Number 18. So, nasa notes nyo naman yun eh. Medyo maliit lang. Mahaba ito lang. Let's try number 18. Okay. Hindi ko na susulat lahat ha. Basahin na lang natin. Sir, a central station is supplying energy to the community through 2 substations. 1 substation's feed, 4 distributing circuits, the other 6. Okay? The maximum daily recorded demands are as follows. Ito yung mga demand. Ayan yung mga demand. Ang question dito, sir, required. Okay? Determine the diversity factor between substation. So, diversity factor between substation. Okay. Diversity factor between substation A. So, diversity factor sa A. And diversity factor between substation B. Diversity factor naman sa B. Okay. So, tatlong diversity factor isa-solve. Sir, kaya ko yan. Madali yan. Analysis lang. Sir, pag sinabing diversity factor, ano pala tandaan natin? SM. Dali mo sa SM, sir, madadivert attention yan. So, analyze. Substation. Kunin mo yung sub. Ano ba yung sub? A and B. Yan yung substation na kinukumpara. Ano yung sa A? 6,000. Okay. Ano yung sa B? 9,000. Ano yung maximum demand nila? Kung para substation? 12,000. So, simplify mo, you get 1.20. Para naman sa A, is, kunin natin yung sum ng mga demand. Ang sum ng mga demand, yung A, distribute mo sa 1, 2, 3, 4. So, ang sum niyan, 1, 7, 1, 8, 2, 8, and then 600. Yung maximum demand sa A, yung kinukuha niya, that is 6,000. Simplify, that is 1.50. Diversity factor sa B, yung sum ng demand sa B, distribute mo sa 6 feeders, so that is 620 plus 15 plus 1,000 plus 29 plus 22 plus 3,000. Okay. Maximum demand dyan is 9,000. Simplify, pag niround off, 1.25. So these are the 3 diversity factors. So madali lang, basta alam yung gagawin. Direct substitution lang. So may sabing diversity, sum over the maximum demand, SM. Chance natin yan. Pag lumabas yan sa board exam, mga variable loading, that is our chance makakuha ng madaling 1 point. Mga points na mabilis natin makukuha. Okay? Ganito lang, huwag kang pumayag na wala kang sagot sa mga ganyang tanong. Pag hindi mo maalala yung gagawin, tsambahan. Mga divide, multiply, okay? Times 2 mo, basta may lumabas. Kaysa wala. Pero mas maganda kung precise yung ginagawa mo. Okay? Pero lahat ng tanong sa board exam, okay? Sagutan mo ng may logic, ng mayroong somehow solution. Okay? Huwag kang pumayag na manghula. Mas mataas yung chance ng educated guess kaysa sa wild guess. So, pag nagtitake kayo ng exam, kahit di mo alam gagawin, gumawa ng logic. Okay? Kahit hindi mo alam solution, gumawa ng solution. Arithmetic, basta may lumabas. Kaysa hula. Okay? Kaysa hula. Pero kung alam mo talaga yung solution, that is the best thing to do. Okay? Sobrahan. Number 19. Okay? Lock-spam ko yan, sir. That is letter? Bilis ah. Hindi natin lock-spam yan kasi ngayon pa lang natin yung solve eh. So, lagyan natin yung solution. Madali ito eh. Na-expect natin yung mga ganyan tanong. So, dapat ready tayo. So, 75 megawatt power plant. So, sir, we have 75 megawatts. Oh, ano yan? Ano yan? Sir, yan yung capacity ng power plant natin. Okay. Has an average load of 35,000 kilowatts. Average load. So, ano yan? Yan yung average or annual load. Okay? The load factor, sir, ito yung Look-Spam. Look-Spam is 65%. Ang question, sir, pre-practice natin to, sir. Ang tinatanong, determine the reserve over peak. ROP. Reserve over peak. Formula-wise, hindi ko problema kasi pag in-imagine ko, kuha ko na eh. Tama? Ang reserve over peak, that is simply plant capacity minus peak load. Okay? Somehow, yung plant capacity given na. So, ang kailangan ko na lang is yung peak load. So, easy problem. Saan ko kunin si peak load? Sa Look-Spam. Sir, ang Look-Spam, that is 8 average over peak. 8. Tama? The direct substitution, 2 steps, 0.65 equivalency sa 35,000 over peak load. Okay, simplify, you get peak load. Uh, 53,846.15 kilowatts. Therefore, ROP, that is the unknown, ROP, equivalent sa plant capacity, 75 megawatts, gawin ko lang kilowatts, 75,000 kilowatts, minus the peak load, 53,846.15 kilowatts. So, ang reserve over peak natin, equivalent sa 21,153 kilowatts or approximately, mubong tatlo, 21.50 megawatts. So, this is our reserve over peak. So, obvious yung sagot, that is letter A. Number 20. Okay, the annual capacity factor of the plant. So we have the capacity factor of the plant na What is the annual? So ito pala tinatanong, what is the annual capacity factor of the plant if the annual energy, so this is the annual energy produced in a 150 megawatt power plant is 500. Okay, 500 times 10 to the 6 na lang ha, times 10 to the 6 kilowatt hour. So this is the annual energy. Okay? In a 150 megawatts. So we have 150 megawatts. So ano itong 150 na to? Sir, yan yung plant capacity. Dinescribe yung capacity ng power plant na 150 megawatts siya. So solution, easy problem. So sir, tinatanong natin capacity factor. Anong concept natin ng capacity? AC. So pag capacity, madali. AC. AC. Okay, AC. So ang tanong na lang sir dito is logic. Kailangan sir, pag factor, walang unit. So find a way, mawala yung units. Sir, mawawala yan eh. Tingnan. Annual capacity is 500 times 10 to the 6 kilowatt hour. This is annual. Ibig sabihin per year. Tama? Annual yan eh. Kailangan ko kilowatts lang. So, ipag-multiply. Umpisado ko na sir. 1 year, ilang oras? 8, 7, 16. Ano yung tuloy? Cancel. Hindi kilowatts. Kailangan sa baba, kilowatts din. So, that is 150 megawatts. Sa gawing kilowatts, 150,000 kilowatts. Cancel out. Natira, CF. Okay, unitless. Capacity factor is 38.05%. AC problem. Okay. Gawin lahat ng pwedeng gawin, basta may lumabas na sagot. Kaya di mo alam gagawin, basta i-divide mo. Pag greater than 1, i-reciprocal mo. Lalabas to. Kaya na pagbaliktad mo, kaya sinasyaban mo yung solution. Sir, alam ko, dinidivide eh. Dinivide ko, di lumabas. Take the reciprocal, lalabas. Kung sakaling mali yung ginagawa mo. Pero kung alam mo talaga, hindi mo mapagbabaliktad yan. Ay, kung alam mo talaga. Uh, 21. Problem 21. So, you can try problem 21. Habang binumbro ko to. Dali lang yan. Lagyan natin sir, the power plant is said to have an use factor 48.5%. Okay? And the capacity factor 42.4%. Okay? Required. Okay? How many hours did it operate during the year? So tinatanong is yung usage. Gaano katagal daw siya nag-operate in 1 year? Solution. Okay? Easy problem. Alam ko naman sir, may relationship yung use tsaka capacity. Use factor, equivalent yan sa capacity factor. Pag minultiply natin ng time. Okay? Use yan, usage. Capacity yan, time in a year. Kasi ang capacity na kayo naka-compute yan in terms of 1 year. Okay? So direct sum. So 0.485. Usage unknown. Okay, capacity that is 0.424. Usage in 1 year, ilan yung capacity natin? 1 year, 8760. Simplify, this is the number of hours na ginamit yung power plant. Seven, 658.23 hours. Let's try number 22. So, dalawa yung nawawala dito. So, let's try. A 50,000 kilowatt plant or steam plants deliver an annual output of 238,000 kilowatt hour. So, we have 50,000 kilowatts. Ano to? Ano yan? Sir, that is the capacity. Describe yung power plant natin. Ayan, ang annual output, so meron tayong average, yung annual, that is 238 times 10 to the 6 kilowatt hour. This is annual, this is per year. Okay. And then we have a peak load, so we have peak load of 42860 kilowatts. We are required to calculate for the load factor and for the capacity factor. Ay parehas, madali, parehas nating alam. Sir, kung load factor, alam ko formula, LOXPAM, that is 8. Capacity factor, yan yung madali, that is AC. Madali, AC. Di direct sum. Kailangan lang, sir, unitless kasi factor at mag-cancel yung mga unit. So, average is given 238 times 10 to the 6 kilowatt hour per year. So, cancelin ko yung year. So, 1 year, 8,760 hours. Okay. Kilowatts na lang. Over peak, given yung peak, 42,860. Simplify, you get the load factor. Two, 3, 8 pala. Sorry. 238. 238. 8 pala. 0.634. Right? So, 634. Dalawa. So, kailangan natin i-continue kasi A or C yan. A or C. Diretso natin. Average, ito pa rin yun. Kukopiyahin na lang. So, 238 times 10 to the 6 all over 8,760. Pinagka ko lang to. Di-divide ko sa capacity kasi capacity tinatanong 50,000. .543. Okay? Huwag magmamadali, baka matulin. Okay? Pag nagsishade na, so that should be letter C. Okay? Kasi nakakalito yung choices, masyadong gulo-gulo lang. Okay? Huwag magkamali. Kaya ito nagkamali ah. Letters yan. Okay? Nagkamali ako ng pag-shade. Letters yan. 634,543. Okay? Letters yan. Ako pala yung naduling. Okay? Let's continue. And then afterwards, let's solve some practice problem na related pa rin dito. Para at least makonsult natin yung time. Which of the following is not a generating stations? So, ano yung natin generating station? Production station. Hindi mo nag-ano yan. Nag-generate ng power. Okay. Which of the following is not a thermal power station? A low head plant. 25. In a diesel power station, diesel engine is employed as prime mover. 26. Systems involving breaking of coal into fine particles, mixing of coal with air, delivery of coal, air to a burner that is called pulverizer or pulverized coal system. Madali makuha sa pagkaka-describe. Okay. The reason generating capacity which is available from the resource but is not in operating is called cold reserve. Hindi nag-ooperate, cold reserve. Demand factor. So demand factor, what's the formula? Okay, so maximum demand over connected load. Demand factor. Reserve capacity can be expressed by reserve capacity. Yun din yung ROP natin. Plant capacity minus maximum demand. So, pinalitan lang yung peak load, ginawa lang maximum demand. Parehas lang naman. 30. Unvarying load on the station, which is occurs almost the whole day on the station. Okay, sir, logic lang sir, base load. Yan yung unvarying load. Hindi ka na nagbabago. Base load. Which of the following is the system of transmission of electrical power? So, sa inyo na to, hindi ko to alam. That is all of the above. Ang electrical na talaga. Okay. The formula for economic voltage between lines in three-phase AC system is given by. So, electrical na to, E. So, that is letter A. Coal is used in power plant known as, the coal used in the power plant known as steam coal. The charcoal, the coke, the soft coal. Ito parang chemistry. What is the permissible pH value water for boiler? Slightly greater than 7. So basic conversion, a 100 megawatt thermal power plant will consume how many tons in 1 hour? 50 tons. Okay, the graphical representation between the discharge and time is called a hydrograph. The spouting velocity is the ideal velocity. Francis turbine is an inward flow reaction turbine. Okay, gas turbine works as, discuss yan sir, hindi yan nakakalito, Brighton lang yan. It's the gas. The diesel engine consumes diesel oil nearly at the rate of, so this is terminology na dapat mabasa, 180 to 200 gram. Which is the lowest temperature of a lubricating oil? Lowest temperature, okay, 4 point. Okay. For the same maximum pressure and heat input, the most efficient cycle is Brighton cycle. Okay. A rotameter is used to measure discharge of fluids. Okay. In bleeder turbines, part of the steam is extracted for feed water heating. Okay. Pelton wheels are installed on Pelton high head with Pelton. Reaction mo, low head naman yun. Reaction. Gas turbine power plant is suitable for ginagamit yung gas turbine sa peak load operation. Then, which of the following plant is the minimum running cost per kilowatt hour? Minimum, so that is hydro. Okay, and then, practice problems. Siguro dalawa lang. Let's solve 2 more problems. Let's try. Or kung gusto nyo, kayo na lang kung mag-solve. Subukan nga ito. Number 1. So this is a practice problem para in appreciation ng topic kanina. Let's try to solve this problem. Madali to. Sir, a gas turbine working on air standard Brighton cycle. So we have Brighton cycle. Okay. Air enters the compressor at atmospheric condition and 22 degrees Celsius. So, drawing ko na lang sir. Ito yung reference ko kasi ang basic drawing ng Brighton cycle. Okay. 1, 2, 3, 4. Pumapasok daw yung air dito at 22 degrees Celsius. So this is T1. Okay? Our pressure ratio is given, RP. Pressure ratio is given 9. And the maximum temperature in the cycle is 1077. Maximum temperature. So, nasan ba yung maximum temperature? Ano yung pinakamainit? Saan? Nandito yun. So, analysis logic set, that is T3. 1077. Question is, determine the cycle efficiency per kilogram of air. So, tinatanong, required efficiency. Okay, madali yan sir. Ganito lang kasimple. Work net over QA. Nagawa na natin kanina sir. Magkakanselan ng mass. Tama? Ang mangyayari na lang, work ng turbine minus work ng compressor over QA. Pag simplify ko, puro temperature lang. Tama? Anong temperature dito? T3 minus T4. Ano dito? O, compressor. Nasa ba yung compressor? Andun, sir. So, ano yan? T2 minus T1. Dito. T3 minus T2. Easy lang. To get the efficiency, calculate for the temperatures. Ay given naman yung T1 and T3. So, isolve ko lang si T2 and T4. How to solve T2, T4? Consider 1 to 2. Anong process? Isentropic. So, applicable yung Tito, Pipito, kick. So, that is Tito, Pipito, kick. Okay? Given. Kabisado ko yung K. Yung P2 over P1, ano yan? Ratio yan, sir. Yan din yung analyze. Pag sinabing RP, ano yung RP? Ano yung RP? Dito, ano yung RP? That is P2 over P1. Ang kailangan ko, P1 over P2. So, ang gagawin ko lang, reciprocal. Easy. Direct sum. So, T1 is given 22 plus 273. Okay. T2 ay plus 273. Equivalent siya sa reciprocal dapat 1 over 9. Okay, 1.4 minus 1, 1.4. Now, I can get T2. Madali lang to. Sakaling lumabas yan, kahit hindi natin na-discuss, kung sinundan mo lang yung discussion, kuha pa rin yan. That is 279.66. 67 degrees Celsius. T2. To solve for T4, ulitin mo yung process. Gawin mo lang 3 to 4. Okay. T3 minus over T4 equivalent sa P3 over P4 raised to kick. Okay. T3 is given. Tama? Ano yung P3 over P4? Ano yung P3 over P4? Ang RP sa P2 over P1 or pwede rin P3 over P4. Ibig sabihin sir, ang ilalagay ko dito, hindi ko na i-reciprocal. 9 na lang kagad. Given yung T3, solve for T4. So kayo na lang magsulat, answer na lang nalagay ko. Okay. Kasi given na lahat. This is 9. Ito is 9. Okay, 447.6 degrees Celsius. So, since meron na akong mga values, substitute sa equation, we get the efficiency. So, okay, substitute, get the efficiency. 46.62%. So, ganun lang siya kasimple. Kaya appreciate mo yung kaninang discussion. Okay, wala naman tayo na miss na lecture. Application lang. Okay. So answer is letter D. 46.62. Okay. But wait, there's more. Ano yun, sir? Pag nagtatanong ng efficiency, basic Brighton cycle, meron tayong shortcut. Okay? Sa totoo lang, ang tawag dyan, masamang halimbawa. Ay, huwag gayahin. So pag nagtanong ng efficiency, pwede yan. Tama yan. Pero mas madali kung ganito apply mong equation. Ang shortcut natin dyan is 1 minus 1 over RPK. Direct substitution, you get the same answer. Okay, so you can use yung shortcut. At least mabilis. Ayan yung shortcut natin. So I think this will be our last problem. Number 2. Okay. Air is drawn in a gas turbine working on a constant pressure cycle. So P1, kaya di na drawing 1 bar. Okay, T1, 21 degrees Celsius. It's compressed, kinompress natin papuntang P2, 5.7 bar. Okay. The temperature at the end of the heat supply is 680. So yung 680 na yan, ano yan? Temperature at the end of heat supply. Hindi ko na ito drawing, visualize na lang sa isip. T1, T2, T3, T4. End of heat supply. End of heat supply. Sir, T3. Tama? Kasi kung ito yung QA natin, papasok yung inlet, ito yung entrance, ito yung exit, ito yung end of heat supply. So this is T3. Expansion, compression is to be adiabatic. Calculate the heat energy supply per kilogram. Heat energy supply. So, tinatanong is yung QA. Okay. Napaghandaan natin ito sa QA, alam kong gagawin. So, anong formula ng QA? MCP delta T. So, ano yung delta T natin? T3 minus T2. Okay? Tinatanong heat energy per kilogram. So, ibig sabihin yung mass, i-assume na 1. Kasi nga per kilogram. So, given 1. CP, constant. T3, given. So, ang nawawala lang, tapos na yan, T2. How to solve T2? 1 to 2. Adiabatic. Pag sabi adiabatic, isentropic. Tama? Sabi adiabatic, isentropic. So, yun pa rin yun. So, T2, Pipito, kick, o given lahat, direct substitution, let's get the answer. So T1, 21 plus 273, all over T2 plus 273, equivalent sa P1, o kaya hindi ka mag-convert kasi magka-cancel lang naman. So 1 bar, pwede yan, over 5.7 bar. Ay, cancel out ito. And then 1.4 minus 1, 1.4, so T2. That is 210.41 degrees Celsius. Therefore, yung heat supply is equivalent sa mass. Tinatanong is per kilogram, so that is 1. CP, what's CP ng air? Ano yung CP ng air? 1.0062 or simply 1. Pwede rin 1. Okay? T3, that's given 680 minus 210.41. Simplify. $469.59, so approximately 470 kilojoule per kilogram. This is our theory. So before I end, meron lang gusto i-share. Hindi naman ako i-share. So, pantulong para sa ating pagre-review. Okay? So we still have 102 days. Okay? Pwede natin yung ma-maximize depende sa gagawin mo starting from now. So para meron tayong direction, so para hindi kayo maging scalar, maging vector kayo. So, ang vector kasi ano yan, magnitude with direction. Ang scalar, magnitude. So anong ka ba dun sa dalawa? So vector ako, vector. May direction. Okay? Para may direction tayo, ganito lang. Pag uwi sa bahay, okay, gumawa ka ng list. Okay, ilist mo yung everyday activity mo. Ilist mo yung mga bagay na gustong-gusto mong gawin, na ginagawa mo ngayon. Kaya sa kumakain, eat. Okay, sleep. Okay, solve. Look, spam. Okay, watch. Okay, ano pa bang ginagawa mo araw-araw? Yung gustong-gusto mong gawin. Internet. Ano ba? Games. Yan, games. Ano ba? Sleep. Meron ng sleep. Okay? After mong i-list, madali lang yan. Lagay mo lang sa table. Okay? Lahat ng bagay na nakakatulong sa review, lagay mo dito. Lahat ng bagay na di nakakatulong sa review, lagay mo dito. Malamang hindi nakakatulong sa review, mga games, watch, internet. Okay? Tapos ang gawin mo, yung mga yan, okay? Ilista mo, tapos ilagay mo sa bagay, sa room mo, na lagi mo nakikita. Sila yung mga bagay na titigilan mo muna for 102 days. Ang tawag doon, delaying gratification. So you need to delay those things or activity in order to achieve a certain goal. Kasi after mo makuha yung goal, yung lisensya, yung title na engineer, pwede mo na silang gawin afterwards. So, taste lang. Kasi 102 days pa eh, medyo matagal pa yan eh. Pero kung unahin mo yung mga bagay na ganyan, hirapan tayo. So, ganun lang. So, delaying gratification lang muna. So, kung may question kayo sa topic natin, lapit lang dito para to verify. Kung wala, have a good day and God bless. Thank you.